Hello everybody, nice to be here at the MENOG event. It's my first time as well. Nice to be in the Middle East, and as Hans-Peter said, warm place is lovely. I'm gonna bring here some stats about IPv6 in the region. First thing is to give you a context to what I'm going to be talking here today. Deploying IPv6 is a multi-step process with different final goals, but for sure you have to accomplish different steps before to get there. So the idea here is to provide some stats that allows us to have an idea on a country level how each country is doing in this process, right? So the final goal is probably to have not IPv6 in itself, but to have a better enable and future-proof network, and that's what IPv6 brings. So simplifying the process quite a lot. The first things that has to be done is to make a decision. I'm talking here stats about countries, but in the end, it will reflect all the networks that are in each country, right? The internet in each country is composed by many networks, and each one of the networks are managed on themselves, and they have to make a decision to go for IPv6. That's the most important step. Back in the days, it was really hard to get that done, but these days is getting momentum. IPv6 is for sure the future of the internet. Well, after taking the decision, one of the first steps is to get addresses. So you need to, if you are in the RIPE NCC region, go to RIPE NCC and get an IPv6 allocation so you can use addresses in your network. You will start configuring things, more or less, bigger or smaller, and at some point you will be announcing those addresses. You will make them available to the rest of the internet. This is a very important step because you're making public to the rest of the world, hey, I have IPv6, send your packets to my IPs, and I will be sending packets outside. That's why I marked that as an important step. But there is much more to go after that. You have to start using it. We will see some stats that will show like LARs, members of the NCC, they get addresses, they announce them, but then they have to use them. And the use could be very different. It could be that an LAR has a very small network, but another one has a very big network, and with millions of users or just a few thousand. Well, depending on the use and the quality of the configuration, things will be better or worse. We'll see some stats trying to figure that out per country. But then, you know, you will continue working on IPv6, you will keep innovating using what's coming in the future, using IPv6, and also I wanted to introduce here the idea that more and more people is trying to achieve an IPv6 only network, and in the future there will be an IPv6 only internet. This is happening more and more, and also that brings another strategy, that is what to do with my IPv4 addresses. So you need also an IPv4 phase-out strategy as well. So these days you have both of them. My presentation is divided into two blocks. The first one is about LARs, so members of the NCC or organizations or companies that have an account and they ask for addresses. So that's very quantitative. And it's basically using RIPE NCC sources. We have the RIPE database where we know which addresses we have allocated. Also we have BGP route collectors gathering BGP information to see who's announcing what. But I also added another source that is publicly available, so you can also look at them later. I added many links on the presentation, so you can later on go back and check more details and look things in the future as well. The first graph shows some stats we generated internally in the region for different countries in the region and comparing them to the overall RIPE NCC region, the Western Europe, and then the average for the whole Middle East region. It shows three things. This is the number of LARs. This is important to understand. This is the number of members in the NCC. No matter how big or small, we don't know that. We only know there is a member that pays annual fee, and they may have only IPv4, so that shows they haven't made a decision yet. Remember the different steps. Then there are members that have taken the decision and they have IPv6 allocation. That's already good. That's the first step. And then the next step we can see in our data is who has addresses and is announcing them on the BGP to the rest of the internet. Here we can see, well, you can see the different countries and how they compare with the like higher level overall averages. We also have per country, we have some data coming from our internal information. Yeah, a little disclaimer there. There is a little bit of a glitch there. There is some information missing for some period, but it's easy to connect the dots and see how things are over time. I can already tell you that you can see there in green IPv4 only LARs. Yellow ones are the ones that have IPv6 allocations, but not announcing yet, and the ones in purple have IPv6 are announcing them on the BGP. This is the good ones, let's call them, okay? There are many things to say about the different graphs. They are quite similar. You can see there are no big changes in the percentages in the last year, couple of years. So no big changes recently, with one exception that I would say is Syria, that sadly they stopped announcing on BGP recently. But the rest of them, we can see the majority of LARs have at least an allocation. That's the yellow plus the purple. And a good percentage is already announcing in BGP they have IPv6. So we can see something similar in the different LARs. Also, there is a difference in the number of LARs per country. Some countries, Turkey, for example, has a quite big number, it's like around 600 LARs, while others have a small number, but that doesn't mean anything, right? We will see also later that the usage of IPv6 does not correspond in some cases to the amount of LARs announcing in BGP IPv6, for example. But as I said before, given a context to the data, it's important to see if the countries have enough LARs. Also going into detail, that can be done to see which ones are announcing in BGP. That's already important, is a good step, is a necessary step. All combined in the region, you can also see here, is similar to the countries. So we have the majority of the LARs having IPv6, and a percentage that is not huge, but is a good number of LARs already announcing IPv6 in BGP. We also can see for the different categories, so no IPv6, IPv6 allocated but not announced and announced on BGP, the percentage of LARs coming from each country. This basically gives us an idea of which countries have more LARs. You can see Turkey has the biggest number, but it's consistent between the different categories. So we can see also Lebanon, for example, or Iraq are the ones that have bigger number of LARs, so they have a bigger percentage in each one of the categories. So, but they are quite similar, so not much information can be extracted here, apart from the number of LARs. Something similar is coming from another source that you can go there. You have the link showing something I think is important to see, and we have seen in the other graphs. We will see three stats here, three graphs. First is the allocation. So these are the LARs from each country that has an allocation, and that's good. That was the first step. We can see, for example, Turkey really has many more LARs, and a lot of them already have IPv6 allocation, and then other countries follow, like United Arab Emirates or Iraq, for example, in the number of LARs with allocations. We can also see how it was growing over time. I think that's also interesting to see. But then the ones announcing prefixes, you can see the numbers go lower, much lower, but still you can see Turkey leading and Iraq and United Arab Emirates following. So similar, lower numbers growing over time as well. And the last thing they are measuring in this source is the prefixes that are alive. So they have some sensor somewhere, they measure traffic, and they see traffic coming from some of these prefixes, and they count them. We can see here it's also similar. Turkey is leading, then United Arab Emirates, and then Palestine, for example, seems to be quite alive. But also a disclaimer, all these sources, what they measure will depend a lot on how they do the measurements, how many probes or places they are measuring from, and how they are connected. So it will depend a lot who measures and how the measures can be different. Something good you will see at the end of this presentation is that looking into many different sources, they show a consistent picture, quite consistent. So you more or less can trust that things are more or less as the stats are showing. So again, this shows how things are been growing over time. That's good to see. This is all about LERs and up to BGP announcement and allocations. So some takeaways about this is that BGP announcement is unnecessary, is quite important to move forward into the IPv6 deployment. If we compare the region in general, we are behind on these LER-based stats compared with Western Europe or the rest of the world. No big changes recently, either on the number of LERs announcing or having IPv6. And there's one exception, that is Syria, that stopped recently to announce IPv6 in the BGP. Also, we have seen how numbers go down from allocations to announcing and then using them. But I want to stress the fact that this is just number of LERs. It's very quantitative, and we will see there is no correlation in all cases with how much IPv6 is being used. Because it only reflects an LER, a network that has an IPv6 allocation, a prefix, but how big that prefix is and how many addresses are actually being used by user infrastructure, that's not reflected in the previous stats, right? We'll try to see something of that in the coming stats from different sources. The first one is a pulse from Internet Society. They have a general IPv6 adoption on websites, 28%, and then a general indicator that you can see is been growing. They created an average taking as a source APNIC, Google, and Facebook's stats. We will see some of them later on. But it gives you an idea that worldwide, 37% of traffic is IPv6. So it's already giving us a hint. And for me, what's more important is it's growing. It's going up. That's good to see. We can then go per country and order. The average on the region is 13%. So we can see two countries, Saudi Arabia and United Arab Emirates, leading. These two countries are consistently doing well in the stats. They are worldwide in the first positions in every stat. So they are doing well. Then we have other countries following, Kuwait, Oman, and Jordan. They are above the average in a good percentage. And then the rest of the countries, Turkey, Lebanon, you can see 1%, 0 point something percent. They are not doing so well. They're way below the average and way below the other countries. It's interesting to, for example, see Turkey is a big country with a lot of networks. We saw a lot of LERs announcing BGP, IPv6 on the BGP, but it doesn't seem they are being used. They are not reaching, providing addresses to end users, right? Because these measurements we are seeing here is end users having IPv6 on their computers and accessing different services out there. We have another source that is coming from APNIC, our colleague RAR. They show worldwide this is for the MENOG region average, 15.50%. They measure two things: if the hosts are capable of using IPv6 and if they prefer IPv6 over IPv4. But they are quite similar in the numbers. From this source, we see something quite similar. compare with the average, we still have two countries leading, Saudi Arabia and United Arab Emirates, and then the other countries doing well above the average, and the Turkey and the others are below, way below the average, quite similar to what we have seen before. But yeah, the ISOC and these ones are similar, same as others. Also, Akamai is a big content delivery network. They offer nice stats. And here we see one example that the measurements can change depending where do you measure and how do you measure. We see pretty much the same as in the others, but there is a very interesting measurement here. It's not because the MENOG event is in Bahrain, but they show 100% of connections coming from Bahrain to Akamai are going over IPv6. That's really interesting. What's going on here? I took a look into the details per country, and you can see recently Bahrain for Akamai, there's been something configured. They are using IPv6 quite a lot, connecting to Akamai. That's good to see, right? The other countries, the big ones, the ones with more percentage, you can see they are consistently going up over time, and there is a solid percentage over time. Is a different pattern. There is another source, this is called Radar from Cloudflare. It's also showing similar values. Something interesting they have is the percentage of IPv6, but also from that percentage, how much is coming from mobile users, mobile operators. Mobile operators worldwide are leading the IPv6 adoption. So this is interesting to see what do they see coming from mobile operators. So let's take a look. So in general, percentages for IPv6, on average, they measured 24.83%. Again, Saudi Arabia and United Arab Emirates are above the average or almost on the average. They're doing well. Same for the other countries as the previous stats. And then looking at the mobile operators, we can see the average is 15.43%. Saudi Arabia is above the average, leading that. And then the other ones are more or less on the average or below. But I think it's worth noting that from the percentage of IPv6, more than a half consistently is coming from mobile users. So that means there are more people using IPv6 from mobile phones than computers or fixed connections. We also have Google. Google also measures how people access their services, if they use IPv6 or not. Something I wanted to show is that they also measure the quality, if people connecting to their services, they're using IPv6 or not, but also if the connectivity is working fine, if they're having some issues using IPv6. So in case there was something red or orange in the map, that means they see from a country problems over IPv6. You can see that worldwide, IPv6 is doing well. There is no issues, worth reflecting on the stats. That also provides some hints on the quality of IPv6, that IPv6 is doing well, no big problems while using it. Something interesting they offer, apart from the IPv6 adoption, the IPv6 percentage of connections going to Google over IPv6, I don't take much time because it shows similar results than previous stats. Two leading countries and the rest of them showing the same pattern. But what about the latency? In fact, I'm not sure what it is, but latency I think is quite interesting to see how do they compare people accessing over IPv6 and IPv4. If it's in green, means IPv6 goes faster, and how much faster you have there in milliseconds. So you can see Saudi Arabia, people connecting over IPv6, on average is 20 milliseconds faster than using IPv4. That's quite good. And also Saudi Arabia, we saw is a big country and with a very high percentage of IPv6 use. But then we see United Arab Emirates or Kuwait, that's also in leading positions. They are doing a little bit worse on IPv6 by these measurements. We will see other ones also to try to see if this is consistent. The other ones, seems there are not enough samples or they are doing similar than IPv4. Something I think is interesting to see as well is comparing IPv4 and IPv6 If the line is above 0, that means IPv4 is doing better. If it's below 0, IPv6 is doing better. And we can see how it improved over time, and recently is consistently for the region below 0. So IPv6 seems to be doing quite well in the general picture, and that's good to see. Yeah. But if we go per country, this is APNIC's measurements, not Google's, we can see they have measured that, for example, Jordan is much, much better over IPv6 when people connect over IPv6 than when they connect over IPv4. And then Turkey, for example, Lebanon, Saudi Arabia. So we can see in general, most of the places IPv6 is doing quite well. The ones doing not so good, we can see that at least they are very low in percentage of IPv6 adoption, except United Arab Emirates. So I think there is certainly something to follow up with and see what's going on in the Emirates and see what's happening with the IPv6 traffic to look worse than IPv4. So key takeaways, all countries except Syria now have several LERs announced in IPv6. That's a good thing because that means they are ready. There are many LERs ready to use and offer IPv6. Saudi Arabia and the Emirates are leading IPv6 deployment in the region, and even at world level they are on the first positions. Good percentage, but still room to grow. We have Kuwait, Oman, and Jordan. And other countries seems to be at earlier stages and have low usage, all the other ones. Interesting to see is how Bahrain appears to Cloudflare measurement, Akamai measurements since mid-2021. 100% of connections going there on IPv6. And also Turkey, we can see here an example that having a big number of LERs announcing BGP doesn't mean IPv6 is spread and widely used on a country or a network. So it's probably a good thing to look into those LERs in that country and see what can be done to improve that. Also, mobile operators are responsible for the majority of the IPv6 traffic. That's not a big surprise. And in general, it seems that IPv6 traffic, the delay, for example, was measured from 2 sources, is better in general, or sometimes equal than IPv4, but in general, lines seems to be doing better. And this has improved over time. There is, again, big differences between countries, so it's maybe worth to check than in some of them. Especially United Arab Emirates, where there is a lot of IPv6 adoption, but seems to be doing worse than IPv4. Also, the last thing to say is we have seen quantity and quality, and to improve the quality, how much things are used and how well they are implemented and used. I think the follow-up will be to look into the key networks, key LERs or key players, to identify the ones in each country by the number of users or the ones that enable others to use IPv6 or connect. It could be they provide transit to others, or their infrastructure is used by other operators. And then focus on moving these networks to the next step. They could be at different moments in the IPv6 deployment, so it's good to see where they are and see how to move forward. So decisions have to be taken based on the local context. Each network knows their infrastructure, their context, how things can be done. But there are global best practices that have to be followed, and and they should be applied in each network. This is all I have. Quickly, I'm from Learning and Development, so we have the academy.ripe.net, Hans-Peter already mentioned. We have the certifications. We will be around. You can come and find us or my colleagues and ask questions. We are offering free exams here during the event, today and tomorrow. Feel free to approach us and take them. Any questions? Yes.
Hello, Alvaro. This is Hisham Ibrahim from NCC. I just wanted to comment on something on your slides here, which is the latency factors that you mentioned. Because it came up yesterday. So yesterday we had the day 0 activities for exchange points, and that topic came out. Because like roughly a decade ago, when we were talking about optimizing IPv4 traffic in the region, it was going all over the place. And that's where we're talking about like keeping local traffic local, building exchange points. That's one of the reasons why we rebranded MENOG as a peering forum to focus on optimizing IPv4 routes in the region here. And I think we've come a long way of doing this. But indeed, as the numbers that you show here, and like I said, this came up yesterday, when it comes to IPv6, the routing is still very much not optimized. That's something that really needs to be looked into, because then the performance will always be worse with IPv6 versus IPv4, which will make operators then turn it on for a while, go the service is degraded, and then go back. So really keeping that in mind is a key thing moving forward in the deployments there. So thanks for showing those numbers. The second thing is, and you mentioned that at the beginning when we were talking about the steps, really ultimately what you want at the end of the day is your end users, your customers to be using this. So going all the way to announcing it is a step on the way, like you said, but really reaching to the end users is key. And I think that's why mobile operators are really doing better there, because it's easier for them to get all the way to the end users. Just a couple of comments, but thank you.
Thank you. Yeah, thank you.
Right.